Welcome to the world of statistics, where today we dive into the concept of multiple hypothesis testing. Now, what is multiple hypothesis testing? It's the procedure of testing several hypotheses at the same time. Imagine a detective investigating multiple suspects. You are that detective, and each suspect is a hypothesis. However, as you test more hypotheses, you also increase the chance of making a type 1 error, or in simpler terms, falsely accusing an innocent suspect. That's a false positive. The challenge here is to keep these false positives in check while performing your analysis. Think of it as a balancing act. On one hand, you want to uncover the truth, but on the other, you don't want to make false accusations. So that's the crux of multiple hypothesis testing. Testing many hypotheses at once while managing the risk of false positives. Now, how do we control these false positives? Enter the false discovery rate, or FDR. This is a method employed to correct for multiple comparisons in statistical testing. Essentially, FDR is the expected proportion of false discoveries, otherwise known as false positives, among all discoveries or significant results. Here's an easy way to picture it. Imagine you're panning for gold. You're likely to find a bunch of rocks along with the precious nuggets. The FDR is like the ratio of rocks to gold nuggets. It gives us an idea of how many of our discoveries are actually false alarms. Unlike other methods, such as family-wise error rate (FWER) methods, FDR is less stringent in controlling type 1 errors. This means it allows for a certain amount of false positives, making it a more lenient approach. So, FDR provides a balance, controlling the expected proportion of false positives without being overly strict. All right, time to walk through the process of multiple hypothesis testing and FDR. First things first, we define our hypotheses. Each of these hypotheses will be tested separately, and we'll get a p-value for each one. Remember, the p-value is the probability of obtaining the observed data, or something more extreme, assuming the null hypothesis is true. Once we have all the p-values, we introduce the concept of false discovery rate, or FDR adjustment. This is an essential step because when we're making multiple comparisons, we increase the chance of committing a type 1 error, that is, rejecting a true null hypothesis. The FDR adjustment helps control this risk. After adjusting the p-values, we interpret the results. Any hypothesis with an adjusted p-value less than our significance level, usually 5%, is rejected. This means we have strong evidence against the null hypothesis. And there you have it, a step-by-step guide to conducting multiple hypothesis testing with FDR. Before we wrap up, let's solidify what we've learned. Multiple hypothesis testing is a significant tool in our statistical toolbox. It's all about testing several hypotheses at once. But remember, the more hypotheses we test, the higher the risk of encountering false positives. It's a bit like casting a wider net at sea. We catch more fish, but also more debris. That's where the false discovery rate, or FDR, comes into play. FDR is our trusted first mate, helping us control this risk. It adjusts the PP values in our tests, providing a delicate balance. It helps us find more true positives, the fish we want, while limiting false positives, the debris we wish to avoid. In essence, multiple hypothesis testing and FDR are about managing the uncertainty inherent in statistics. They help us navigate the vast seas of data with confidence and precision. Remember, in the world of statistics, it's all about managing uncertainty, and tools like multiple hypothesis testing and FDR help us do just that. Until next time, keep crunching those numbers.